In this training session, we're going to look at the EventSentry NetFlow daemon. NetFlow, if you're not familiar, is essentially a protocol usually used by gateways such as firewalls, but also switches that sends traffic and metadata to a NetFlow collector. So a firewall, for example, will send you information as to which IP address is connecting to which other IP address, which protocols, source port, destination ports, and also how much data is being transferred. Some of the newer versions of the NetFlow protocol can also include other metadata in addition to just the traffic, but EventSentry currently only looks at pure traffic IP and TCP UDP traffic data. NetFlow essentially allows you to see what's entering and leaving your network, and you get visibility into your network traffic. NetFlow is configured just like the other components that are part of the network services here in the management console. However, NetFlow also has two add-ons that are configured under the global options because these can also be used by the collector. And these are down here under geolocation and threat intel. The first one is the Abuse IPDB token. So the Abuse IPDB is a community-sourced online threat database, basically, that can give you additional threat information on IP addresses. If you have a subscription with them, then you'll get a token. You can paste it in here, and then the NetFlow daemon in EventSentry will, every time it processes an external IP address, get threat intel on that IP address and provide that in EventSentry. So if a threat has been found, then you'll be able to see that information directly in EventSentry. You'll see things like, has this IP address engaged in port scanning, phishing, and so forth, and what's the threat confidence, which is usually the most important indicator. What's the percentage of that we think that this is a threat. Then we also have a GeoIP database file. EventSentry ships with a GeoLite database from MaxMind that gives you some fairly accurate information as to where that IP address is from. Down to the city level. There are more accurate databases available, so if this is important to you, you can go to MaxMind and you can purchase a subscription and get more accurate data. But the default database that ships with EventSentry is included for free and gives you some basic country and city information. So now let's take a look at the NetFlow daemon. Up here we have, of course, a checkbox to enable it and pick the ports. In most cases, you won't have to change the ports. NetFlow is 2055 by default. SFlow is 6343. SFlow is slightly different than NetFlow and is usually used on switches. And works a little differently. Switches usually process a lot more data than firewalls. So SFlow usually just samples the data and usually only sends every 10th or 100th packet to the NetFlow collector. So it's not as accurate and useful, but in secure environments, or if you have a switch where you absolutely need to see the traffic data, it's still useful. The next checkbox below is aggregate flows. Whenever a host downloads data, it's not usually in a single packet. It's usually dozens or hundreds or thousands of packets. When you check the aggregate flows checkbox, the NetFlow collector in EventSentry will try to aggregate similar flows that go together into a single record in the database. So for example, if you're downloading a 50 kilobyte file, instead of having, let's say, roughly 50 records in the database, each indicating that one packet was sent and a few received, of course, for acknowledgements with TCP as well. Instead, you would just have one record in the database saying, okay, 50 packets were exchanged. So you really don't lose any information. It's just that the records are aggregated. You won't have the exact timeline down to the millisecond, but for the amount of data that passes through networks nowadays, that is fairly irrelevant, and definitely recommended to keep that option checked. You can also have the NetFlow component calculate the bandwidth of a specific interface. EventSentry will try to obtain the interface speed, which is of course required to calculate a bandwidth via SNMP, but you can also set that manually. And you can also control from which NetFlow hosts data is going to be accepted. Now to the familiar database tab. Again, here we control where does the NetFlow data actually go. By default, we're writing every NetFlow packet that we receive to the database, and we can also exclude certain data. So for example, we could say, well, I do not want to write ICMP information, then we could exclude ICMP from being written to the database, or vice versa. Of course, we could switch this around and say, okay, I only want to write, let's say, TCP information to the database. So those are some of the options that you have. So you can pick from any of these protocols that are listed here. We're going to leave the default here. You can also, of course, pick a country. So if you wanted to say, I don't want to log anything from Germany, then you could do that, or vice versa. Event log has a few more options. So event logging in NetFlow is generally geared towards a couple of different things. One, detecting port scans. So I'm going to enable this so we see this down here, and alert on suspicious IP addresses. I'm going to actually start from the bottom since it's a little more straightforward. Since NetFlow has access to all traffic that's being sent, it can detect if a single IP address connects to multiple TCP ports. And here you can enable and trigger an alert. So if a remote IP address scans at least 250 ports within 15 minutes, and if it doesn't send more than 250 bytes, because if it sends more, then it's considered actual traffic and not just a port scan, then that will trigger an alert. You can also get event log alerts if traffic has been detected from a potentially suspicious IP address. And of course, that goes back to the threat intelligence that we configure up here, threat intel. In most cases, that can result in a lot of false positives because a lot of IP addresses on the internet are considered suspicious. But nevertheless, you can set this up and you will get an alert whenever an IP address that was interacted with is considered suspicious. You can improve on this and reduce the number of false positives by checking this box. And you can basically say, only alert me if this specific IP address transferred more than a certain number of bytes. So let's just say 100 kilobytes within a certain amount of time. And let's just say 5 minutes, 300 seconds. So now if a potentially suspicious IP address simply just, sends 100 or 500 or a kilobyte, then you won't see an alert. But if that suspicious IP address actually transfers at least 100 kilobytes of data, then you will get an alert. So this is kind of useful because if a host on your network communicates with what's considered a potentially malicious IP address and transfers, a fair amount of data, and again, you can define that, then you probably want to know about this. And then finally, you can also create more simple static rules based on either the protocol, which is probably not something you'll use, but on the GeoIP data. So for example, if you say, okay, I want to get notified, it's the Zimbabwe, all right? Okay, let's just say you want to know if somebody if a host on your network communicates with Zimbabwe, then you can add this here. So, and you can create multiple rules. You can add any country that's in the list and get notified. So to summarize, here we define the protocols that we're listening on, and enable the whole NetFlow collector. Aggregate flows is generally recommended. We specify the database we're writing the data to. And as far as event logging is concerned, we can detect port scans, we can detect suspicious traffic, and we can also detect data that's transferred to specific countries. And don't forget, some of the global options here also apply to the NetFlow daemon.